Let's begin by reading the example and highlighting important information. When a new charter school opened in 1994, there were 290 students enrolled. Write a formula for the function n of t that represents the number of students attending this charter school t years after 1994, assuming that the student population, and then we're given 5 different scenarios. So I'm going to go back and here write a formula for the function n of t. That's also our goal. Or that is our goal. N of t is defined here as the number of students attending. So let's write down our given information and define our variables. So we know that t equals the number of years since 1994. So we got that from here, t years after 1994. N of t represents the number of students attending the charter school in year t. So we will put number of students t years after 1994. And we were given one other piece of information that's common for all of these problems, and that's that in 1994 there were 290 students enrolled. So if we think about our ordered pairs, that would be t and n of t. T is the input, n of t is the output. In 1994, t is 0, and there were 290 students, so n of 0 is 290. So let's start with this information. Let's build up some tables, look for some patterns, and then develop our formula. And along the way you may see some patterns that will help you do this more quickly, but for now let's just try to make sense of this. So a table is a good way to do that. So we have t and n of t. And in the first scenario, it says that the student population is increasing by 36 students per year. So let's see what this might look like for some integer values. Well, we know that year 0 is 290. We start with 290 students in 1994. And now, 1 year later, we have 290 plus 36 students. And I'm not going to compute this yet because I want to look at patterns, so this is a good way to see patterns. 2 years later, we have the 290, but now we're going to have this 36 students plus another 36, or we could think of that as 2 times 36. 3 years later, we'll have the 290 students, the original students plus 3 times 36 more students. Okay? And now I'm just going to fill in here, this was 1 times 36. And notice we can also think of this as 0 times 36. So now let's look for patterns to make a general formula. So I'm going to put t here for a general formula. And notice that in every single case, we have 290. And in every single case, we have 36. But what's changing is the number we multiply 36 by, and notice that directly corresponds to the t value. So we could say that in general, n of t is 290 plus whatever t is times 36. Okay? And to think of this in terms of linear functions, we know that our rate of change, what it's changing by per 1 year, is going to be 36t. Okay, so this is equivalent to t times 36. We usually write this first. You don't have to, but we usually do. And then our initial value, 290, Graphically, we could think about this as the vertical intercept, or in this context, it's the initial value when t equals 0. So this is our formula. N of t equals 36 students times the number of years past 1994 plus the initial 290 students. Let's look at the next one. Notice I have cleared the table for our next problem, so if you need to see the previous one, you can just rewind. So now we have decreased by 24 students per year. So we're going to start 1994, there's still 290 students. But now, year 1, we're going to have 290 students, and we're going to subtract off 24 students. 2 years later, we'll have 290 students, but we're going to subtract off 2 groups of 24 students, totaling 48, but again, I want to see this pattern. 3 years later, we have our 290. We lose another 24 students from the previous year, and 3 groups of 24 students from the original year, so 3 times 24. And again, we could think of this as 1 times 24, and we could think of this as 0 times 24. So now, in general, we can see 290 stays the same, that's our initial value. 24 stays the same, that's our rate of change. Also, the minuses are staying the same. We're subtracting that off every time. And what varies is this value, which corresponds directly with t. So if we want to make a general formula, we can write 290 minus t times 24. And in general, we can write this formula. So this form is fine, but kind of our y equals mx plus b, or our slope-intercept form. We would write the coefficient first, and we'd think of this, instead of subtraction, we would think of this as a negative 24t if we write it out front, plus 290. So here's our initial 290 students, and with every increase in t, we subtract off an additional 24 students. So negative 24t plus 290. Let's look at the next example. In this case, we have increased by 20 students, but now it's every 2 years. So notice here we had increased by a number of students, but it was every single year. Here it's going to be every 2 years. So let's just look at this and look for patterns, and then we'll see if we can come up with a general strategy. So we know in year 0 we have 290 students. Now 2 years later, we are going to have 290 plus 1 group of 20 more students. 2 years after that, we'd have 290 plus 2 groups of 20 students. And let's just do one more. 2 years after that, we'd have 290 plus 3 groups of 20 students. So let's see what stays the same. Well, 290 stays the same every time. The 20 stays the same every time. Our input, the t, is varying, and these values are varying, but notice in this case they do not directly correspond to the t values. Notice the t value is twice as large as these numbers, or we could think of these values as half the given t value. So in general, we could write this as, for the tth term, we have 290 plus, we could take t, divide it by 2, and multiply by 20. Now notice, cleaning this up, we have a common factor of 2. So this would be n of t equals 10t plus 290. So you may have noticed while I was writing, I was kind of leaving spaces that I didn't leave before. And the reason is I wanted to show you a pattern. So notice here it increased by 20 students every 2 years. So 20 students, I'll put ST for students, every 2 years. Well, 20 divided by 2 is 10 students per year. And notice that's what we had when we simplified this expression. So here, if we think of 20 students every 2 years as our rate of change, to find a unit rate of change, we can just simplify 20 divided by 10. That will give us the rate of change. So this one is 10 times t plus 290. And looking back, notice that here we were given unit rates of change. Decreased by, this was a negative 24t. Increased by, this was a positive 36t. And in every case, we started with 290. So now for the next one, let's see if we could take what we've learned so far. You can still make a table if you want to, but to move more directly to this formula. So this says decreased by 48 students every 4 years. So decreased by would be negative 48 students divided by every 4 years. So now if we simplify this, negative 48 divided by 4 is negative 12 students per year. Okay. So notice if you thought about this as simplifying a fraction, you'd be left with negative 12 students over 1 year, which gives us the unit rate of change when we have the 1 in the denominator. Now we know that we began with 290, so this is our rate of change, negative 12t plus 290. Okay. So notice that process was a lot quicker than the previous ones, but this gives you a good feel of looking for the patterns in the numbers. Now we have one more left, and here we say that it remained constant. It did not change. So did not change, so we're going to make a quick table. So that means in year 0, 1, 2, 3, 4, no matter what, we had 290, etc. We could think of it as we added 0 people in this year. There was no change in the second year or in the first year, so we have 1 year, but we didn't add any. Year 2 still remained constant. So in general, we have 290 plus 0 times t. Well, 0 times t is just 0. So we could represent this constant function as n of t equals 290. So it did not change. Notice it really has a slope of 0, like we saw with horizontal lines. So here's the 0 times the t. So no matter what the t is, it doesn't affect the output. So that's why the t part isn't shown when we write our formula.